All right, you guys, today's episode is going to go into a little bit of an exploration. We're going to use a website called wolframalpha.com. Great website. Put it on your phone, put it on your tablet, your device. In page 796, we are discussing what happened in the previous page where coins were flipped, and after they were flipped, we looked at their probabilities. This scenario talks about flipping 50 coins. Now, I'm not going to sit here and flip all these coins for you, but I wanted you to consider what would be the odds of flipping 50 coins and the first heads, the first two coins show heads. So just for the simple demonstration, there's the first coin, yo, I flipped it. There's the second coin, it's been flipped, but every coin after that, up to 50 of them, is flipped. And as that flip happens, we're just letting it, be a thing. Derek says, for the total number of outcomes, I multiply 2 by itself 50 times, which is 2 to the power of 50. Little asterisk note here. That's an exponent, and exponents mean the base, so 2, times 2, times 2, times 2, times 2, times 2, times 2, until you've written down that 50 times. Mean 2 times 2 times 2 times 2, 50 times. It's whatever the exponent is, which we should already be okay with that, right? We should be okay with the fact that there's 1 out of 2 outcomes for that coin to show up. There's 1 out of 2 outcomes for that coin to show up. And when we do the mathematics with probability, we mean to multiply them. So if you have 50 coins, you're going to have to multiply times 2 50 times. 2 times 2 times 2 times. That's a lot. Let's go see what Wolfram Alpha says. By the way, as I read it, Derek says it is, let's see, this is units, thousands, millions, billions, trillions, quadrillions. 1 quadrillion, 125 trillion, 899 billion, 906 million, 842,624 different outcomes. What? Okay, let's just see if you did that right. Wolframalpha.com, 2 to the power of 50. By the way, the little it's this symbol, my mouse is showing up on screen. That's called a circumflex, and it's shift 6 on the keyboard. And yep, there it is. 1 quadrillion, 125 trillion, 899 billion, 906 million, 842,694 different ways that you can flip a coin. So Derek's not wrong. He definitely did that. I'll read it. I'll leave this up on the screen for its just majesty for the moment. There is 1 desired outcome for each of the first 2 coins, but for the other 48 outcomes, there's 48 arrangements. We don't really care about them. That means 2 to the 48th power. So, well, it's on your book, and I'll show you the book in a second. I'm actually going to write 2 to the 48th right here. Okay, 2 to the 48th, and then again, group in 3. So units, and then thousands, and then millions, and then billions. 281 trillion, 474 billion, 976 million, 710,656 arrangements of the next 48. We lost some because of the double and the double again. Let's just check here. Did Derek say that same number? Let's see. Take a look. It looks like, yep, 281 trillion, 474 million, 976 billion, million, 710,656. So he's certainly doing the mathematics correctly. 2 to the 48 means 2 times 2 times 2 times 2. 48 times. Then he does some other simplification here. He realizes that he can take that 281 trillion number divided by that 1 quadrillion number, and he can rewrite them in exponent form. And a fact about exponents is if the bases match. Time for blue, because this is a totally random fact. If the bases, that's the big numbers with the little exponent up on their shoulder. If the bases match, then you can just subtract the exponents. So subtract 48 minus 50. Or certainly the other way is cancel 48 times. And when you cancel 48 times, 2 2's will be left on the bottom. And then when you reduce that 2 squared, remember, 2 squared is 2 times 2. The little exponent says multiply the base times itself 2 times. Okay? So, yeah, he comes up with 1/4. All of this, right? All of those coin flips don't matter. It's only... Maybe that's the conclusion. I won't steal the conclusion, but I want you to think about what Serena might say. She might have the more advanced thinking in the process. Serena says, I only need to do calculations with the probabilities for the first 2 coins because the probabilities of the other 48 are 2/2, which is 1. 2 outcomes, 2 total outcomes, 2/2, 1. The probability of flipping heads on the first and heads on the second is 1/2 times 1/2, aka 1/4. Who do you think is right? Who has the easier method for figuring out probabilities? If you can resolve that, sure, 50 different events, but the last 48 of them are all 1/1, 2/2, like they're all the same. We don't really need to consider them. We need to know they exist. Derek is acknowledging that those events exist, but Serena is saying, that hurts my brain. I want to use the simpler, more efficient method. A rule of compound probability involving AND states. If event A and event B are independent events, then the probability that event A happens and event B happens is the product of the probability that event A happens and the probability that event B happens, given that event A has happened, or this way. You multiply the 2 probabilities. That only specifically, definitively works with no issues when independence has happened. We're going to need to be very careful with what happens when we have dependent situations, but maybe we'll see how they're very similar. So page 797 is the next video for us to watch. Thank you for watching this video, like, commenting, and subscribing. Go ahead and click forward to the next one because 797 is next. 797, that's a palindrome. See you in the next episode. Like, comment, and subscribe.